Good afternoon, everyone. I just wanted to go through a lesson with you via video. I'm trying to do this with my phone attached to a tripod. Not quite sure how well it's going to work, but hopefully you'll be able to see what's going on here as I work through it. So, what I'm going to ask you to do before you go through this lesson is make sure you do your homework that was assigned before the March break. Make sure you review your 4 quantum numbers, because that's going to be really important when it comes to this. And have this periodic table out. You have a copy of it, and have your regular periodic table out with your elements, because we're going to work through that as well. So first of all, just a reminder that you've got 4 sets of quantum numbers. Your N is your main shell, your L is your type of orbital. So those are your S, P, D, and Fs. That's what the periodic table is based on. And then the MLs, those are your specific orbitals. Those are the ones that house those electrons. Those are your MLs. And then your MS is your spin, your up and down arrows that represent clockwise versus counterclockwise spin. Another reminder here as well that your S is now, your L equals 0 is now named an S. It has 1 orbital, the ML, with 2 electrons. Your P block is an L equals 1. There are 3 of those orbitals, a +1 to -1. Your D has 5 orbitals, a +2 to -2. Your F has 7 orbitals, +3 to -3. So where are they on your periodic table? Well, that's what this is here. So your S block can only be 2 electrons. So that's groups 1 and group 2, alkali and alkaline earth metals. The P block are groups 13 to 18. There are 6 elements as you go across a period. Each one has an electron that fills your P block. Your D block are the transition metals. The block in the middle, there are 10 elements that fill a row in the D block, which means 10 electrons divided up into, or spread out into 5 actual orbitals. And then your F is 14 electrons in 7 orbitals. So you have 1 orbital with 2 electrons, 3 orbitals with 6 electrons, 5 orbitals with 10 electrons, and 7 orbitals with 14 electrons. Okay, so when it comes to locating an electron, you can actually pinpoint what shell it's on, the number, which orbital type it's on, and when we draw it out, we can state whether or not it's in the +1, -1, or -1, or sorry, 0 orbital, depending on whether it has a +2 to -2, +1 to -1. Okay. So if you have your periodic table out, I'm just trying to find mine here, you'll notice that on your periodic table, okay, so these are your S blocks, your P's, your D's, and your F's are these ones in here. You can actually see the atoms now and know where they are. So the way the filling works is you start up here at the top. 1s. So this is N equals 1. This is an S block. 1 electron for hydrogen, 1 electron for helium. Then you go to the N equals 2, which is your next row, and you have 8 elements in that row corresponding to 8 electrons. 1 from lithium, 1 from beryllium, so on and so forth. So when you're filling, you just follow the periodic table. So you fill the 1s first with 2 electrons, hydrogen and helium. Then you're going to fill the 2s with 2 electrons, and then the 2p with 6 electrons. Then the 3s with 2, the 3p with 6, the 4s with 2, and then you hit the transition metals. And the way they work is their value is 1 less the N value. So if you're on N equals 4, your first D is a 3. So this is a 3D, and then it goes back up to a 4P. So when you're filling, to get your 18 electrons, 2 of them come from the 4S, 6 of them come from the 4P, but 10 of them, the remaining 10, you have to go to the N equals 3 shell and fill it up from there. And that gives you the 18 electrons you're supposed to have on the N equals 3. Okay. When you get to the 5s, your next D is a 4D, a 6s is a 5D, and then your F's down here, your F's are 2 less the N value. So if you're on the 6th shell, your F is going to be a 4F. So D's are down by 1, F's are down by 2. Okay, so that's what I was saying here, that these are 1 less the N value, these are 2 less the N value. So what happens when it comes to electron filling? Okay, let's just get this sheet here. Okay, so the first thing we're going to do is recognize that as you go up in energy levels, your energy increases. So this is an N equals 1. The 1s is the L equals 0 orbital, which is the ML0, and it has 2 electrons, 1 for hydrogen, 1 for helium. So 1 for hydrogen, 1 for helium. Then that gives you your 2 electrons that you need according to the 2n squared rule, according to Bohr. Then you make this big leap up here to the N equals 2 shell, and now we have the 2s, lithium and beryllium. So 1 electron for lithium, 1 for beryllium. This is the L equals 0 with an ML of 0. The P is an L equals 1 with an ML of 1, 0, and negative 1. So the 2p is this block here, and you just fill them up. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And so now we get 2 electrons from the S, 6 electrons from the P, and that gives us the 8 electrons we need in the N equals 2 shell. Then we jump up, but not as high, to the N equals 3. So now we're on shell 3. So we have a 3s, and over here a 3p. So the 3s is the L equals 0, the 3p is the L equals 1, ML 0, ML 1, 0, negative 1. So filling up in the first orbital, you're allowed 2 electrons. So go into your periodic table, 1 for sodium, 1 for magnesium. Then you go to the P, and you'll have 1 for aluminum, silicon, phosphorus, etc., etc. So 1, 2, 3, 4, 5, 6, and that 6th electron gets us to neon. So that's what the filling would look like if we stopped here. That would be the filling for neon. So we have 2 electrons from the S, 6 electrons from the P, but we have a problem because on the N equals 3, we need to have 18 electrons here, and we only have 8 represented. So let's keep going. Those other 10 missing electrons have to come in somewhere. So after the 3p, following your table, you go to a 4s. So you're now on shell 4. So we leap up to shell 4, and we put 2 electrons in, 1 for potassium and 1 for calcium. Now we've hit our transition metals. That's the D, and it's a 3D. So your next energy level up is going to be a 3D. So notice how they're staggered, the S's, then the P's, then the D's. And a 3D has more energy than a 4S, even though it's in the lower shell. So the 3D is this entire row here, all 10 atoms with each having an electron that it contributes to the diagram. So this is your L equals 2, and it's a +2, +1, 0, -1, -2. So we put 1 electron in at a time, and then we pair up, because according to the Pauli exclusion principle, you add 1 at a time, and then you go back and pair up after that. Okay, so now the 3D, we're now at zinc, and we know that the 3D contributes 10 electrons. So now we have our 18. So here's the 3s, 3p, 3d. There's your N equals 3 shell with 18 electrons. Here's your N equals 2 shell with 8 electrons, and your N equals 1. So as you go up, the volume gets larger and larger and larger, and there's more overlapping because this 4s and this 3d overlap. Okay, to keep going, after your 3D, you now go back up to shell 4, because the P's and the S's will always have the same N, the D's will be one lower. So this is now a 4P with 6 electrons. So 1, 2, 3, 4, 5, 6. So now we have a 4S, that's our L equals 0 with 2 electrons. We have a 4P with 6 electrons. And we know on the N we need 32 electrons. So where do those 32 come from? Well, let's have a look at that. There's the 4S, there's the 4P. After the 4P, we go to the 5S. So we go up to a 5S and add those two. We're now at strontium. Then we drop back down to the 4D, and we say drop down because it's a lower energy shell, but actually a 4D has more energy than a 5S because it's a higher orbital, because Ds are higher than an S. So we're going to put in all 10, so 5, and then pair up, and now we have 10 electrons. So we have 2, 6, 10, that's 18, but we still need 32. So let's keep going. So after the 4D, we go back up into shell 5, a 5P. So this is full with 6. So there's the 5P full with 6 to xenon. And then next row down is a 6S. So that's where we go next. So you just follow the periodic table. These are always S's, these are always P's, and these are always D's, and the period number is your N value. So we have a 6S. Now you've hit the F's. So where you see this, that's where your F gets inserted. So now you're going to drop down 2 energy levels to a 4F, and you're going to put in all 14 electrons. So after the 6S, you don't go to the D, you go to the F first. You'll put in 7, and then you're going to pair up. And now you have 14 electrons here. So now you have 2, 8, 18, plus another 14, which gives you the number of electrons that you need, the 32. So when you look at that shell, look at how big the volume is now. So the reason why you can get 32 electrons is because you get 2 from the S, 6 from the P, 10 from the D, and 14 from the F. And then it just keeps going on and on and on. So larger volume, in overall increasing energy, but the energy differences get smaller and smaller as you go up, because the other thing that happens is all this overlapping. Okay, so let's apply this now. We're not going to be going this big, but I wanted to show you what it looks like. So let's apply this now to some actual examples of atoms. So have your periodic table out. Okay, so the first one we're going to do is beryllium. So beryllium is right here, Be. And to get to Be, you always have to start at hydrogen. So hydrogen is period 1. It's in the S block. It has 1 electron. And then after hydrogen, you go to helium, because that's the other electron in the S. And there's your energy level diagram for helium. But we don't want helium, we want beryllium. So we keep going to the 2S. And we put 1 in for lithium and 1 in for beryllium. And what you'll notice now is we're done. We stop there. So that's your energy level diagram for beryllium. Simple as that. To identify the type of magnetism. So ferromagnetic elements, there's only 3. Iron, cobalt, nickel. Paramagnetic means you have temporary magnetism due to unpaired electrons. And diamagnetism is no unpaired electrons. So we're going to say that this has no unpaired electrons to align in a magnetic field. Therefore, it is diamagnetic. Okay. The second one we're going to do is sulfur. So if you locate sulfur on your periodic table, it's way over here. So we're going to start with hydrogen, and we're just going to go across the table. So sulfur is going to be a little bit bigger. You always want to build your energy level diagrams up. So we're going to start down here with sulfur, and we're going to start at hydrogen. So we have a 1s, 1 electron for hydrogen, 1 for helium. And then we do a 2s, we put in 1 for lithium and 1 for beryllium. Then we go over here to a 2p. We're going to offset this, 1, 2, and we know there's 3 of them because there's 6 electrons max you can put in. So boron, carbon, nitrogen, and then pair up oxygen, fluorine, neon. So that's what neon would look like, and you could see it has no unpaired, so it would be diamagnetic. But we don't want neon, we want sulfur. So now we're going to go down to the next row, which is a 3, period 3 in the S. So we're back over at sodium, magnesium, and then going across, we're at the 3p, and sulfur is the 4th one over. So 1, 2, 3, 4, and that's your energy level diagram for sulfur. And what you're going to notice now is it has 2 unpaired electrons that align. So these will align in a magnetic field, and because it's not iron, nickel, or cobalt, it is paramagnetic. So you can magnetize sulfur. It'll be a temporary weak magnetism, but nonetheless it can be done. Okay, so the next one is krypton, and krypton is way down here. So again, we're going to do the same thing. We're going to start with hydrogen, and we're just going to follow the blocks on our table, remembering that when you get to the D block, it's 1 less N value than the period number. So krypton, we're going to have, start here, we're going to have the 1s, so hydrogen, helium, 2s, lithium, beryllium, 2p. So now we're going to go from boron all the way over to neon. After the 2p, following your table, 2p, we now go to row 3, which is period 3, and we're back in the S block again. So that's a 3s with 2, and then a 3p, all full. So singles, and then pair up. So now we're at argon. And then we're going to do a 4s next. So I'm going to go up here to a 4s. And I kind of squished my space here. But so now after the 4s, now you're in the Ds. It's 1 less. So this is a 3D. And to get to krypton, you have to fill it. So we're going to go over here, 3D, and put in our 5 orbitals. And we're going to fill it. Put in 5 singles. Pair up to 10, and then after the 3D, we're back into N equals 4 again for the P block. So this is going to be a 4P, and it will be full because krypton is a noble gas, and that shell is full. So now, when you look at this, you should be able to see that there are no unpaired electrons to align. Therefore, this is diamagnetic. Okay. All right. The last two are biggies, but what we're going to do is we won't start tantalum at the beginning. We'll pick up where niobium is. So let's do NB. So locate NB on your periodic table. And you'll see that it's number 41. So we're going to be putting 41 arrows. It's just a matter of putting them in the right spot. So we're going to start up here with the S, and we're going to go all the way down to number 41. So instead of me walking through it with you again, I'm going to be silent, slowly fill it, and I want you to try it. If you'd like, or you could just wait for me to do it or walk through it on your own by looking at the table. But nonetheless, I want you to try to work through it and then just check your answer with me. Okay, if you're not done, you can hit pause and finish, but I didn't finish. I only got up as far as I did with Krypton because we haven't gone beyond the 4P yet. But again, you just follow. So there's the 4P, and then you're going to go over to your 5S. So we're going to put in a 5S here with 2, and that puts it as strontium. And then we're into the D again, but if the one above is a 3D, this is one higher, it's a 4D, and 4 is one less than 5. So that makes sense. So we're now in a 4D, and you'll notice that NB is the 1, 2, third one over. So we're going to put in 1, 2, 3. And that's the energy level diagram for NB. Again, type of magnetism, you have 3 unpaired electrons to align. Therefore, this is paramagnetic. Okay. Now, the last one, niobium. I'm going to do this one here, NB. Okay. What I want to do with NB is I want to start at the 5S. So let's start at 5S so we don't have to redo all of this. So 5S. Okay, so after the 5S, we know according to our table, because tantalum is down here, so we're one row above it still, so we need to do our 4D and then jump back into our P block, which is a 5P. So we're going to do a 4D over here, 5 orbitals filled with 10 electrons.